Okay, let's start. Prepare your sheets as usual. Because each day starts from
Ничего нет, апгрейдить.
don't worry.
Да,
Okay, before quiz, I'd like to handle what we get about Azure Group. And after this, we will start because today quiz on this topic.
About
Yes. So, at least in Wikipedia, you have information which helps you. Actually, why? So, what is it? Like, what did you get?
No. This method of not easier. Yeah, but what is in Wikipedia just not. No. Wait, they like. If you determine a Astro group, you can say, okay, this adds no degree of freedom. That's why we can simplify it differently.
Oh, you just like you discarded from calculations. That's what I understood.
Actually, yeah, each Azure groups, you can just eliminate it from the this group. You can just eliminate it and return it again. So, for instance, if you have some mechanism and you know that Azure group, actually, I'll help you. Now, it will be on a quiz, but I help you to decouple it. Yes. So it's our quiz. We started now 45 minutes. So you have this mechanism, and actually, so the task is to find kinematics and velocities for D. You don't need to solve it. You need to provide a solution. Let's call it algorithm. But you need to put equations for this. I mean, equations like I'm explaining. You write the equation. You don't need to derive some value. You just need to write I derive this value and so on. So you can decouple this mechanism on this mechanism and this guy. So this guy is another. So you can solve this task. Just decouple. Firstly, solve this guy, and after this, solve this guy.
So we can see that BD is rotating around point C.
It's you may assume that it's beam, but it have one extra connection.
So it can move just like this.
Yes.
It doesn't move linear mode.
No. Okay. It's something like this. Yes. Like Romysl in Russian.
И плюс по point C. Окей,
So да, то есть it fix and this fix and
okay.
Any questions? You know all length and you know this you know this motion. So as usual, the common task, but you need to solve it in general. It would be nice if you write, for instance, I decided that it's this kind of mechanism, we know how to solve it, or we don't know how to solve it. Write your thoughts. If you're too lazy to write in English, you can write it in Russian. But not in Arabic, sorry.
What is like the last sentence? Third base position.
I mean that actually it's better to put some value there. You know this position. You know the coordinates of this guy. Try to remember the previous task when I provide you angle 60 degrees from the 1. It's the same. I mean, you know this coordinate.
This point still is like
Yes, you.
I have. Then we have all lengths and TB. Is it a fixed length or not?
TB,
Yes.
BC, yes. BD or BC, no.
B, B. No, I said I'm saying CD.
Post non.
Okay.
TB fixed. А D у тебя двигается. Коромысло, алло. D это как вот этот слайдер. D слайдер. It moves forward. You need 5 extra minutes. Can give you.
Because we don't have personal.
Yeah. Can you elaborate what that is? So, how was this mechanism? The switch. The switch is
Well, I wrote 5 equations for me. And
This length and this length changed.
So BC is also changed.
no. The thing is, like, it's rotating around C.
Yeah.
But it's fixed. The Y is fixed. The height is fixed.
Okay, BD is
No. B is no. C
Okay.
is not fixed.
Okay. 3 minutes extra, and after this, I explain how to solve this task. It seems you need to have more formula.
Can you see it? What? I mean, I finished.
Actually, it's not, no. But,
Thank you.
time's up. Okay. So, how to solve this task? As I told you before, you need to decouple this mechanism to mechanisms. First mechanism is folding bar. We covered it on previous class. how to find it? I mean, if you want to find kinematics, you need to find intersection between the circles. Again, it was in the previous class. So this circle, and this circle. After this, we can find all needed angles for A, O, A, B. Of course, it's better to write it. We find coordinates, and after this, using cosine rule or sine rule, doesn't matter, to deliver all stuff. Okay. Now we have all angles. I mean, so we know this coordinate, fine, and this coordinate we also know. We need to handle this somehow. We have one more. So if we cover it with this part, it will be a through group. What it will be? It will be intersection between two lines. One line, of course, yes, it's from this, but if you know this angle, you can find it as well. And this line, I provided only this, I wrote it, is horizontal. So you have only one direction. So your question will be A equal to something x. Да, у нас y. Why is it? Because you have constant y and x will change.
Yeah. So y is equal to x. So y is equal to k.
Yeah. So, and this line, you can find it because you know this angle. You know 2 points. Actually, you know 2 points already. Because you know this point and this point. You can receive equation of the line using 2 points. That's it. Is the reason why I told you that geometrical approach is quite easy for this kind of task. Eric, did you get it?
No. Write the equation, please. I don't understand.
Okay. From the beginning?
Write the equation of motion for.
Yes, probably.
Okay. Okay. So, because we try to find kinematics, not about those. Because for velocities, you just need to use a plane of motion or not so tough. Okay. So A, B.
X and Y for A. X, A, Y. Equals to which point was that? Right. A. No. I mean XA minus X.
No.
Which X? You have X without subscript. Which X?
This point?
Right.
This is for the circle. Doesn't have.
I'm asking about the question of motion of point A.
How to find point A? Okay. A is just, let's assume that angle theta.
Y is sine, sine for X, sine for.
Thanks. After this, yes. Minus it. Thanks. We just put it there.
I still don't understand which equation. How to use it.
again, what you didn't get?
You wrote the equation of the circle. Like,
Yes.
okay, how you will derive from it the coordinates for
For B. See, we need to find what it will be if we have point A.
Yeah, it will be radius.
Yes. So if you make motion, you will receive, even if you write it in parametric form, it's more intuitive. You will receive all points on this radius. We write for C. For C, it's for, it's A, B, sorry. A is the center. So CB, this circle. We also know this base, as I told you. So in this case, you can write x minus x c square plus y minus y c and bc square. This x and this x are equal because we try to find intersection. So you write a system of linear equations and you receive non-linear, sorry. System of non-linear equations and you will find b. If you find this coordinate, after this you can use either robotics, when you change the frames or whatever as you like, you can find angles. Or even you can just make, OB.
How exactly
You find OB because you know B coordinate.
okay.
You know OA
Uh-huh.
and you know AB. I think you can find all angles using cosine rule or sine rule.
So solve the two equations, you get the second point.
Yes. Of course, you don't need to do it manually. You need to use computer web solver, as I explained before. Okay, you found all angles. After this, hooray, we found B point. We are going to this point. We want to find D. How we can do it? First of all, we need to write the first equation for this line. D third base because I didn't want to change the picture. As I mentioned before, we need to know. So the whole equation is x minus x0 equal tan something like this. We have tan equal to 1. Tan 0 because we don't have angle. We don't have b. Tan 0 compensate equal to 1. Yes. Yes. It should be like this. So
Fine over
0. Okay. Там же
You need to find the equation for the horizontal.
for horizontal line, yes.
Yeah, it's just y. Y equals k. Any x, it will find the equation. So just you have one constant which is y, which is k.
y equals k, x equals k. Like it's easy for
Yeah.
no, that's not. K is constant.
K is constant.
We can choose 0.
Yeah, in this case, yes. Okay. In parametric form. And this one, you have B and C. You can write x minus. Okay. I supposed to receive like actually it should be x, yeah, x, yes. Done.
What are you trying
I'm trying to shape.
y equals ax plus b. Now you substitute y and x. Firstly,
Yes.
for point,
So yes, we know this point, this point.
and we know first.
Yes.
And after this, we will press in.
By
You know, it's when later.
just 1 point.
Yes, you can find this. After this, you just need to solve this equation.
It's all good, but if we can plot it.
If you want, you can program. I mean, on computer.
I want.
You want to show the mechanism?
Okay. Actually, you have almost the same task on your phone. Because now you just let's say declare the algorithm, and at home you can do it and check that it's correct. Okay. I didn't receive any questions from the class, so we'll skip this part. First task, it's your task, so you need to solve. So you have 10-15 minutes. Try to solve it on your worksheet, and after this, let's discuss. So let's go briefly through the task that you will get it correct. So we have this square. It makes some plane motion. We know the length as usual. So the task provides us the accelerations for point A and point B. It's A, B, B and A. So we want to find AC. What again?
Mean acceleration.
Yes, the full acceleration of. I will come in fact.
So good.
Sorry. E. That's all.
It's a base round point. It's the X and Y.
So like A subscript A is like the acceleration of
Like it's where a unit vector would be.
I think it's rotating around the center.
It's around.
What?
Angular
acceleration
around
what?
around.
I guess around point B because
Yeah,
it's the
yeah.
center of point.
Yeah, you're right. Yeah.
But acceleration do that. Ah. So if we put vector acceleration A script A from acceleration D vector, we can like we can draw perpendicular and it will go to point B.
It's already the A subscript A is already perpendicular.
Yeah, but why? So
he already divided the acceleration to
Okay.
tangent.
So
and,
yeah, that was my
normal.
question. Why? Yeah. So he already.
Yeah, he already divided them.
And did we find full duration of points T or just tangential?
We should find a different tangential and normal.
Right.
Why exists from what?
Like here arrows for points T. Why direct for points?
Yeah, I don't understand why. Like from A, there's this direction X, and then from C, there's a direction
So
Y.
how it's like basically about any point around any point.
Ah.
It cannot be direct. Like this vectors around point A, like not vectors, just arrows.
Yeah, the arrow. Yeah. I don't get it.
Wait. Rotates. Then do a direction. Ну типа. А это не. Блин, это же еще к центру направо. Не. Точно. Оно в центре. Понял. Problem is if it's point center, you cannot rotate. Why not? Because like if you rotate in this direction, you produce like this acceleration, and here it should be opposite. No. Yes. No. It rotates around point B. It cannot like point like this, like where must be. I don't know what the second error means. I just thinking about point B. Like I suppose if it's rotates around point B, AB is like the ratio of B. AC rotates around point B while making motion like either. But it's not plain no. Like rotational translation. I also think that acceleration for A is not on the angular, but also rotation.
This is not acceleration. So it rotates like this, and at the same time goes like this in order to compensate for.
Plane.
Have you had rotating plane when you can translate this?
Yeah. Just moving like this.
So since they drew this direction, like assume it
So
rotates
it
like this.
So it rotates not around B, but around some like.
No. It can rotate it from B.
But then B like moves.
At the same time it moves.
Well, let's just agree that it's moving this way.
I guess like this. Yeah, but like
Okay. It's moving this way.
yeah. Can we say that if we have angular acceleration for C, it's equal for angular acceleration for A? Because
Plus direct relation with respect to velocity of v and plus the velocity of c with respect to v. Yeah. So and we can get velocity of v according to equal to a plus velocity of v with respect. This is like a relative, like we something to it. But I think with other part that we can like get the instantaneous zero velocity. I think if the velocity is the same direction, so the instantaneous center velocity will be in v, right?
Yeah.
So velocity v is equal to angular acceleration multiplied by a.
Why?
Because like you are like as you are rotating around the
But
center.
you said
velocity of
that
a.
the center.
Yeah, so velocity of a is equal to angular acceleration multiplied with the a. And then we can
So I hope you solved the task.
You did not even understand it.
What?
Because this square like moves like this, right?
Yes.
Okay. We managed to understand.
Yeah, we did that.
And A is only like component of the of not like
It's full.
but like squares.
I didn't get this.
not all.
It's spoiler alert. I have to eliminate all.
Actually here.
Because like there are two components, like translational acceleration, tangential, and normal. Frequent. And they add up to a.
Okay. Danya, how was your?
I didn't find it. So basically, since we
Let's discuss about algorithm.
so we first need to understand what's going.
We
managed to know is this is both rotatory and small. Otherwise, it cannot like just rotate because acceleration point to each other against each other. It cannot just rotate. We found that if just rotatory, now we need to find a point of rotation is the same and draw vectors. In this diagram, we can see that they can rotate around B, but from C and from A to B, there should be normal acceleration.
Okay, I see. Okay, let's go a bit apart. We have this task. We have a lot of accelerations, but if we know that our plane rotates, we need to find angular velocity and angular acceleration. It's our first task. After this, we can think about other stuff. Why? Because angular velocity and acceleration applicable for every point on this let's say on the body. Yes. In this case, we can so as you remember, linear and angular, we can go from one part to another part. It helps us to solve other tasks. Okay, how can we do it? We have A and B accelerations. So we can write the equation A equal AB plus AB. Do you agree with it? We know this and this guy, we need to find this guy. This guy can be expanded in two. I mean, not I wrote accelerations, but Yes, we.
Acceleration AB is angular acceleration.
No. AB divided into tangential and normal. So, what we can do with it? How can we find it? Okay,
But
one of it is omega AB, other epsilon AB. Yeah. Okay. How many variables do we have there?
We have epsilon and prediction. We don't have the we get it.
You need to, of course, we wrote it, but we need to get what the, let's say, can we divide, can we receive two equations from this?
We can do the same thing.
No. It's in vector form. Each vector form can be put on the basis. You can use projections. Yes, you have scalars. One of it is normal, another is tangential. So one equation provides you a pure omega. I mean, pure. So one element of it will be on y-axis. Other will be on x-axis. I see you didn't get. Okay.
right something.
No, I get it. I think how to. So as I see, you probably didn't get what let's say tools do you have to solve the task.
Just write something.
Okay. So we need to how to say put it on the basis. So we have x-axis and y-axis. Все? Покажите. Твой проблемный.
Записываешь, да?
It seems we need to turn off the camera.
Why?
Она работает?
He asking does it work? No. Okay. So for x-axis, okay, polar will be that. I just want to change it, right? It's normal because we find a respect to b, and it will be a tangent. So for x, we have ab cosine 4 to 5 plus, we don't have tangential, it will be equal to 0. But we have normal. Normal is what?
Epsilon
Equal to 0.
Why is it?
Because a in x-axis will be 0. We know this guy. We can take epsilon from this guy.
So you say like normal acceleration of point A is x component of total acceleration of point B. So like we can just remove all arrows, just say there's acceleration in point B and all others like produced by.
Sorry, but what is it exactly?
So we have x-axis there.
Okay. So we are projecting on that.
Yes, we just project on the x-axis. So it's one of the common tools when I explain about vector form when we discuss. So you can just you wrote it in vector form. After this, you can multiply your amount of equations, and if you choose the right basis, it will be easier to. Of course, mainly we have just this basis, but we can change it if you want. it will help you soon when you will cover the say on rigid bodies and so on. And probably next class. After this, we just need to understand where it will be normal and tangential. You can do it using you can put velocities or whatever you like. Actually, we know that it should be normal and tangential. The same stuff you're doing for y. A b sine phi plus okay minus doesn't matter now because we need to understand the idea and a. Hooray, we did it. We found angular velocity and acceleration. The next step is Tanya.
You know, rigid body, all already. So, radii. Find the radii.
Actually, yes, we can just write AC equal AB plus ABC. Probably you need just to dive into this and get probably it won't have enough equations, but you also know that AC equal to AA plus AC. So after this, you can receive 4 equations, and I'm sure that it helps you to solve the task because you know velocity for both of these velocities and accelerations will be the same, and you can and you know all angles, so you know both AC and BC. You just need to expand it and solve. I'm asking you in home task to solve the task fully because in this case you can first of all get the tricky moments in some cases, and when I solve it manually by my hand, I totally understand that I solve it correctly because we should cover it. Now we have only 20 minutes, but we should cover one more topic. It will be spherical motion, and I will solve it on the whiteboard.
But you say the numbers after the lecture, I want to.
Yes, actually, I didn't get why he gave you Coriolis acceleration before the spherical motion. Because yesterday, on Monday, you had the acceleration, Coriolis acceleration, yes, but it's strange. Actually, even in books, firstly, you need to solve Coriolis acceleration or for spherical motion. After this, you go to this guy. We used to solve on your home task adaptant version of Jablonski. So K4 is today quiz task or this task, for instance. This one is K4. Spherical motion is K6. It will be your home task. And K7 and K8, it will be Coriolis. It's just the number of tasks. So I didn't get, so we didn't synchronize with him. Is the reason why I explained today Coriolis stuff. Okay, Yarek, did you get the algorithm how to solve this test? Okay, try to refresh it. Explain it first. What you have this task. What you need to do first?
First, you need to determine which point around which point it rotates, like which motion it does it.
Okay, it's already wrote that explain motion. Okay.
Yeah, explain it clear, like but how it moves. So, like previous.
Why do you need it?
Just to understand to.
Okay, it's for you. Actually, for the task you don't need to understand.
Yes, but
okay.
It's the worst part when you like writing something.
I agree. Okay.
It's bullshit.
Yes, I agree. You get it.
Okay, so like we see here that it has AB acceleration and like angular acceleration, like in some place we're supposed to move like this and also rotate. So, like Okay, then we suppose that the instantaneous center of rotation is point B.
Actually, you can choose another. You could take A and find it with respect to B. I explain why it's not a good idea.
This arrow, like,
Daniel, do you understand why it's not? Yes, to choose a pole. Take another pole.
I know.
Yes, because you have 45 and you will have a very nice time to draw correctly all points. Actually, it's your home task, special home task. So, no, but if you want to understand it, actually it's all for you. I think it would be nice.
Yeah.
Try to solve this task in one direction using, as we discussed now, A is a pole, B is a pole, and find A.
I would like to ask if it is possible to provide on paper a solution for the task.
and also not paper, but code which shows that both equations are correct, and it moves like it's supposed to.
Illustrative way. And
Yeah, and also
it would
code.
be perfect for like this year.
Because we wrote a shitload of equations and we don't even know if they're correct.
Unfortunately, I have rigid positions plus your code plus this, and I can help you there because I'm writing on my. I can take a photos of my.
No, your handwriting is.
Yes.
I agree.
So I'm showing you algorithm, and
Still-
you need to see it and implement it. If you cannot, find other
We
sources.
don't even know it.
Yeah,
Correct,
so
you
I
can
want to
support.
attend labs and that thing. What is the purpose of
Yeah, you need some like material base.
Material base.
At least, okay, like perfect task, how it looks like. You have a task, like description. You can solve it on paper, like a full solution for each point, for different points. Okay, pages of solution. And then all those equations, you just copy them into code and like draw the plot and like show the plot. You see it like intuitively, it moves correctly. Like it's supposed to be right. Like you can't like say that it's correct because it's like, but at least you will get the idea. Because
Okay.
now like you wrote the equation, like and we can't even speak how we will trajectory of B, A, C.
Is the reason why you have this guy.
home task?
Yes. Home task. You can code it and understand that you're correct, that you did it correct. Actually,
This is another.
I took all our home tasks from this and just translated to it. One of the why I wrote that is from
Translated and shared. This is also.
Yablonsky.
It's
No,
Jablonski.
there's another one like in the movie. English.
Mishersky, yes.
Yeah, this is has a.
If you found Yablonsky in English, it will be perfect.
This one is Jablonski.
Yes.
Because
It's
like-
in Russian part. Actually,
I think so.
about it. Why I wrote that K4 because some of you already know that it provides a task, but you cannot just copy paste their task because I updated it because we need to simulate and write code. So it's the reason why sometimes I had to change it. But it provides you a solution for the not advanced task as ours, but for base task. You can open it. You ask me a solution. Open Yablonsky, and just
Jablonski like he just finds the instantaneous speeds, accelerations, and so on. He doesn't like show trajectory. It's a more difficult task. than
yes,
supposed
I
to.
told you. But for trajectory, we covered that you can use vector approach. Oh,
Yes.
so we covered in the there. I'd show you when I. Okay.
Don't do any plots here.
Okay. I imagine. Okay. Draw 12 times. Don't plot like
Yeah,
that.
it's not to draw it 12 times, you have to like use Python. So, this task, like, we need to see how, at least I need, maybe all people are genius, we understand it from first time, I need to see how it moves. You understand them correctly. Because, okay, first impression, I see this task, I see 3 arrows from point A. What is it?
It's spoilers. Don't think about it.
It's, this whole task is spoiler. Spoiler.
Danya, what are you trying to do? Okay. So, Yarek, I'll try to try to at least make someone home task using code. I cannot guarantee that it will be on each lab, but at least on some of them you will receive code.
It's okay. Like previous home task was okay, but for me, I didn't get how to solve the problem before Dania sent me like last unit vector. Like I couldn't simulate like this even point. No idea. No tools which you provide. But maybe I could use it with
12 minutes more. While
No.
okay, so I will explain this task is spherical motion, but let's. I want to say some relaxed stuff about missed slides about bobsleighing, but let's drop it. You can Google by yourself. Actually, it's about lesson planning. It was a relaxed part. As previous was a Gopnik part. I mean, like to sit like a true Slav. Today was a bobs. Have you heard about it, please, someone?
No.
I want to explain it because most of you will either taught someone or will teach someone. Actually, I used to use it. There is a video, 3 minutes.
Box is a lesson planning model designed by a group of Canadian post-secondary educators.
Because I thought that we will solve it faster than we did it now. So we need to cover at least one task. But now, as a relax, I will explain your big home task and your home task. Okay. Read it.
This is I will explain. This is different than the other one of the book.
It's this. You have big home task.
Yeah, but there's another home task
This
with
yo-yo
camera
task.
and
It's the yo-yo task.
No.
No,
You have two big home tasks. Second one is yo-yo.
Why you publish?
Yeah. What about the
Yo-yo it.
cruise?
No. Wait a second, because let's open Moodle because it's important.
You accidentally.
Okay, I put your scores. No, I started to do it, but okay. See, we have one big. I see. I see. I hide the second. I hide the first one, but I forgot that I put second one.
Yeah.
Okay, I get it. Okay, I will hide it. Don't worry. It's analytical mechanics, as you may see, and so don't worry. If you get, as I remember, I didn't put any time for this too. So now you have one big, and I put description. I just put this one to slides. Yes, it's on slide, but actually yes. And you have big two. This 6th of September, again 2 weeks. And one big is 13th of September. So next, it's you need to solve it before midterm. Yeah, so it's the end of the 4th week.
So midterm will include kinematics and stuff?
No, just kinematic. Okay.
Because like the professor said that this is the last thing to do. Kinematics.
Okay, I will say him that you are not ready. You are not ready at all. No, so informally, but in yes. So this guy, we have a mobile vehicle. Assume it's a robot. We have some preferred trajectory, which is given. It's in our case it will be some harmonic function. Like this. Yes. Of course, we want to. It's a race, and our robot should move as fast as possible. So we can represent in our case this robot is the particle material point. Okay, material point. And of course, we have to put some constraints. I already did it for you. First of all, it's about max tangent acceleration. It's max power of the motor, because actually Did you get the intuition between normal and the tangential acceleration? What each of it provides you? Do you remember the equation of normal speed in terms of curvature? But do you remember what does it mean curvature and k? Because it was in your whole field compass. And
reciprocal rate curve rate. So basically, the more you have curvature, the more you have.
yes, so see, yeah, tangential always tangential always provides you the tangent, so it doesn't provide you any direction actually. In things not in terms of coordinates but in terms of path. Only normal acceleration provides you the direction of your movement, because in this case you know that your robot moves this way, but tangential provides you only amplitude of your acceleration. It's quite important for this task. It's the reason why tangential acceleration, max tangential acceleration, provided the max power of your motor. At normal, it's normal. It's road adhesion, because we don't want to have drifting fast. Because it will. Because yes, otherwise your wheels will be slipping and so on. So it's why we have this constraint. It's real constraint in real robots. So how should we move speed accelerator for solving such tasks?
We have trajectory.
Sure.
And
You need your robot should. So you have trajectory. Your robot should move on this trajectory. So you
need to reconstruct it basically.
You need to. So you have some trajectory. Your robot should move on it. I mean, point by point. You need to define velocity acceleration. Actually, you write some kind of control, yes, for this point, and you want to do it as fast as possible. Did you get it? Okay. So I proved A, B, C. So you need to provide tools, solutions, and plots. Now I'm explaining you some tricky moments. See, today for this week, I expect you that you just read it, think how to solve it, probably start to do something. On next lesson, I mean, the Monday, you can have some. You probably will have some questions, and we'll cover there. 3 tricky parts. Trapezoid velocity. Do you know what is it?
Trapezoidal velocity.
Yes. Do you know what is it? Actually, your robot cannot start so you have velocity respect to time. It's gonna start like this. So your robot should start to move like this. One, boom, and of course you should stop.
This is the velocity.
Yes. So it's trapezoid. I will actually. I wanted to provide you some.
I would like to ask you,
yes.
What is the difference between the velocity control and because like both of them like get the same graph of position somehow.
No. Trapezoid is not about this one. Trapezoid is about, let's say, in general. You want your robot should. You want that the robot should move as fast as possible. It's not about PID control, because it's about how, in general, your robot should move, and you try to, let's say, have max accelerations. Will be your max time acceleration. The full acceleration. After this, we need to have our velocity, blah blah blah, and after this decrease. Of course, it's ideal situation, and it won't work for our case. Why? Because your robot should slow down on some point. Intuition should give you that probably these points and not only these points. And your real velocity will be like this. Also about acceleration. Acceleration, it will be derivative.
So basically, we need to reconstruct the function from
I didn't get.
You have acceleration.
About
you can control
about trapezoid. Actually, it will be on your next semester. I asked your future TA to provide me materials because we can spend about 20 minutes and can explain it. But it's better when you have a book or something like that.
Who would be the future TA?
Mike Astanin, he was my, let's say, classmate when I was a master student there. Second is manipulation between coordinate and natural forms. As you have to manipulate, you have to work with natural form. We're talking about path. Because only in this case, at least I solve this task using this approach. When you in this case, you can decrease or increase your velocity. I mean, accelerations and so on. But you need to know when you need to know the coordinates when you need to slow down. For instance, I mean, we want to find this position or this position. We have path. We're going bam 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 bam. But we need to know that it's precise coordinate when we need to slow down. In this case, you need to use the equation from the first lab. As you remember, I highlighted it. You need to solve optimization. Actually, I can provide you code in MATLAB. Like, not code, probably a function which I use. Solve it. Or you can do it numerically by yourself.
Yeah.
I did it firstly by myself, but the problem was that if you put a very high discretization, I mean, a very frequent. In this case, my computer solved it 20 minutes. Yes, I received a quite good plots, but it was not so nice. When I put not so well, I mean more discretized, I lost some pipes, so it wasn't correct, and I lost time. Because you remember, you need to do it as fast as possible, and our grade will be based on it. So if you, for instance, your robot will finish it in 7 seconds, okay, A, 7.5, B, and so on. So based on it. For instance, one guy solved it, his robot was faster than mine when I solved it. He optimized his code better than me. It's the reason why A it's less than, not just some particular number. And curvature, as I told you, you need to cover this part, and you can do it using curvature problem. Because in this case, you will get OK, or not curvature, but the K1. This time you have 2 weeks in total, 2-3 weeks to solve it. Till 13th of September. About your home task today.
So you are using non-speak for that question.
Yes.
Yeah, okay.
Yes, I translate it and sometimes add some additional tasks because we try to code it. Okay, always. No, for today I just put simulate. You need to simulate it. That's it. Because actually this task was he didn't ask you to find. Actually, in most of the tasks he didn't ask you to find. Let's say in general in all positions. In our case, you just need to find kinematics, and in this case, you can. One extra task from Yablonsky is just find kinematics for this. That's the difference. That's it. So using simulate to find velocity for all points is the reason why I provide you only 2 home tasks, not 1. Oh, not 3. 2 instead of 3, because it's a bit routine task. No.
What?
20 years.
What is this?
It's again as from the quiz.
So,
Actually this one, it connects. So in one link we connect some other link.
Okay. And this link is like moving. Oh. We can rotate them.
We can rotate, but this will be. It's a line.
Okay.
Yes, it's yes.
But what is the like usage for such mechanism? O3 FE.
Or actually, I don't know. Probably. Okay.
So if we remove
Malaretov explained it on this class, but as I thought, he didn't. Do you understand why do we need theoretical mechanics? If you were in 60s, 70s. Yes. The problem is that before, the motor costs very high. It was so expensive. So the guys try to reduce the amount of motor. You can, as you probably get it from the previous when I showed the vehicle suspension and so on, you can receive, if you know this topic well, any equation of motion for some point. So you can design a mechanism and receive and obtain the trajectory which you need. Now we have cheap motor. Of course, not so cheap. It's not so cheap as a burger, but it's much cheaper than before. Now we can put just motor, and that's it. We can put a lot of motors in our robot, and we don't need to think about trajectory. But in some cases, it's applicable, and you will get it on the next semester when you have a course pro on mechanics and machines, which I will be taking. And also, it's in this case you can get how to work. This is like kind of toy examples for now. You can understand how to operate with velocity, acceleration. Actually, I showed your doctoral thesis of Moaletovs. It's not state of art, but I mean actually it's really in the industry project, and he used theoretical mechanics. There are yes.
That's the question. You remove OCF. This mechanism from
free FE.
Yeah, from the whole mechanism. Is there something you change?
The constraint, like it gives the
Actually,
most.
you can check it. You will have contours. You need to simulate it, eliminate it, and see how to will look.
No, from your experience.
My experience.
No,
At least this F will move. It probably we can put there a marker, and it can draw something if we need it. Forget drawing. It seems it should actually it's our actuator. So this guy moves because of this, not vice versa.
Yeah.
So it's master and this way our mainly
so it's something like wood with them.
probably. So of course, but you can check as I told you. You need to get your home task as I told you probably in linear algebra. You need to assume that how to say you have some assumptions, some ideas. When you solve it, you need to put your assumption, check it. In this case, you will get how to work with this stuff, with all the stuff. Okay, I didn't get my advice for you. Find the book where it's better to find the answer where it is. Probably in Michers you can find answers, even solutions, because there are a lot of solver books. Yes, it's in Russian. Probably, I think some of you can help you, or I can if you ask me. Okay, you have a solution, you have answer, but you didn't write solution firstly. You solve it by your hand. Okay, did you receive the answer? Yes. Is it correct? Fine. After this, even if it's fine, you need to okay. How can I solve it in different way? For instance, in vector form or in geometric form, and check it. If you receive the same answer, fine. In this case, you will have your experience will be really high, and you can solve it. So when you ask me some questions like this, try to sit and just yes, you will spend not 10 minutes for solving the home task. Of course, you will spend 2 or 3 hours, but in this case, you can solve it. I know that it's not so fast. Because in previous year when I learned it with my students.
So why you are TA?
Why? In which? What do you mean?
Like last year, you are learning with them.
Why I'm there?
Yeah.
Because first of all, I need to dive into this topic. Second, I need to. I'm a PhD student. I'm a PhD student. I have some experience, and I spent 2 hours per week to understand how to solve it. Of course, you should spend much more time. Yes, because I sat with Malaletov and we solved tasks together.
Where is the product of your understanding? Well, why didn't you bring us some plots, some programs which you're supposed to write?
I explaining you now.
See? Oh, thank you, Kayyo.
Okay, about second task. It seems yes. As I understand, you are not ready to work today. Yeah, I will write equations. I mean, I will write down how to solve this task. And not this task, but this task. This task.
Also, like the previous, yeah, this task is not from Miguel's. This is from something else.
Yes, something else.
The Indian guy.
Yes, from Indian guy. Yes, it's from Indian guy. Yes, it is. So this task. I think I will just sit. I will write down the equations on the sheet and make a video because some explanations are needed there. For instance, it's from the book and it's not very correct as they did it. So they had some mistakes. It's the reason why I left you several minutes ago, because I found this mistake in the book and the Malaletov agreed in the mistake. So what else? Probably.
Didn't you tell that the author proved that?
Actually, I did it 2 times. No, it's not. Who cares? Actually, I had a Java course, and we had a book, and we found 2 or 3 mistakes when we studied, and we wrote to the author, and he said yes, one of the mistakes were found, and on 2 mistakes, he wrote it in his site that this particular student found this mistake, and we will change it in the next. Okay. Okay, I get your feedback that you are too lazy to do by your own.
What? You've seen it, I said.
No, I'm talking about that you want to have more plots on the.
Of course, because you write okay. At first, like lab, you didn't do anything. Okay, now you roll some equations. Okay, good progress. On the next time, please write equations and show that they are true. What man?
Yes, like draw, right? Really like
MATLAB screenshot.
Form like solution, like 1, 2, 3, 4. Not something like
yeah. Not
like
saying that
like this. It's really confusing for students.
Not saying that just okay, but like how I understand it. You say, oh, intersection between 2 circles. Don't say like intersection between 2 circles. Like plot it, show how it will look like. What does it mean?
And maybe like other things that would be very easy for you to provide like a written solution on a paper instead of like writing on the board and provide this solution. It would be like perfect. Like YouTube videos that provide like a question here and they are drawing and they are like solving tasks very formative way, and that's it. Will be like perfect. And a lot of tasks. Put tasks as much as you can.
No, thanks.
To begin with, just solve one. Just show it.
Okay, if I solve 1 or 2 tasks using MATLAB no free. Let's trade. Hey, someone should clean up the whiteboard for me.
And if you do this, no one is going to clear the whiteboard.